All right, this is a video for the quiz for Unit 5. So the first question says, what are all the real cube roots of 125? So we want to write that as the cube roots of 125. If you know this one, you can just write it down. The answer is just 5. If we want, we can check it out. We can put that in here. We want to do a cube root, so we got to go into the functions menu, scroll all the way down to the nth root, and then the cube root of 125 is just 5. And that's because 5 times 5 times 5 is 125. For the second one, what are all the real fourth roots of 81? So we have to do a fourth root of 81. So because this is even, so remember this one was odd, so we could just kind of write down the answer. But since this is even, when we have an even index, we need to do a plus or minus. So to do a fourth root of 81, again, if you know it, it's just going to be 3. So plus or minus 3. If you have to double check, you can come over here, the fourth root of 81, and you can see we only get 3 as a result. You have to remember the plus minus for the even ones. If it's odd, remember our functions, the odd ones are just functions themselves. The even ones, though, you can get 2 results. So we have to make sure that we do that. All right, for number 2, it goes. There we go. It says rewrite the fifth root of 9 to the third power using a fractional exponent. So to rewrite these using fractions, the base stays as the base, the exponent stays as the exponent, and the index becomes the denominator for the exponent. And that's it. We're all done. We do the same thing over here. We get 9 to the 3/6. Now with this one, 3/6, we can actually simplify that. So if we want, we could write that as 9 to the 1/2 power. Now we could also solve that. I mean, that's just 3. But we want to rewrite it using a fractional exponent. So this is what it looks like as a fractional exponent. Just remember, since this index is even, this could be either positive or negative. All right. So for number 3, explain what 8 to the 2/3 power means and evaluate it. So 8 to the 2/3 power is the cube root or the third root. So if you want to use an ordinal number, you could say third. If you want to use the vocab, you could say cubed root of 8. And then what you're going to do is you're going to square it. So you're doing this one first, and then you want to square it afterwards. So again, if we're using the vocab words, we would say squared. If we want to say to the second power, we could say to the second power to use an ordinal number. The vocab words are a little bit easier because you can see there's a little bit less to write, but it's your choice. Its value is, well, the cube root of 8 is 2, and then 2 squared is 4, so its value is 4. If I didn't know what value that was, again, I could type that in, 8 to the 2/3 power. So we go 8 to the 2/3 power, and we see it's just going to be 4. Since the 3 on the bottom, since the denominator is odd, we know it's not a plus minus. It's just a regular, whatever the answer is, whatever the answer is. All right. For number 4, we want to simplify this expression. So we're doing the fifth root of each of these things. So we want to rewrite it as the fifth root of 243 times the fifth root of a to the 10th times the fifth root of b to the 25th power. All right, well, the fifth root of 243, again, if we wanted to, we could try and figure that out. So let's see if it works out. That's the first thing to do, is always see if it works out. So the fifth root of 243 is just 3. So we're done at that point. So we can just put a 3 down. Again, since it's an it's an odd, that means that whatever answer we get is the answer. For the other two, though, we want to simplify them. And to simplify them, we want to put them into fractions. This is going to be a to the 10 over 5. And this one's going to be b to the 25 over 5. So now I see I can actually reduce these fractions. So a to the 10 over 5 is really a to the second power. B to the 25 over 5 is b to the fifth power. So final answer will be 3a squared b to the fifth power. For part B over here, we see we have a fourth root, so we know that we might have a plus minus. So let's see what we got. So first thing we want to check is see if we can do the fourth root of 32. So we'll plug it in. And if we do the fourth root of 32, we see it doesn't work. So we get all those decimals. That means that we can't just write down the decimal. If you write down the decimal, it's wrong. So what we want to do is we want to split it up. into something that we know the fourth root of. So fourth root of 32, we'll do fourth root of a to the 10th, and then fourth root of b to the 24th. So we know this one doesn't work. So we need to get something that we can actually take a fourth root of. So I have to think, what are my powers of 4? And I know what 2 to the 4th is. 2 to the 4th is 16. Well, 16 times 2 would be 32. And the fourth root of 16 is equal to 2. So here I've got plus or minus 2, fourth root of 2. Now I can work with the next one, and just like we did with part A, we want to rewrite this as a fraction, so 10 over 4. 10 over 4, though, that doesn't come out nice. What we want to do is think of this as a to the 2, so that would be 8 over 4, times a to the 2 over 4, because we'd have 4, 8, 10. 2 plus a half is 10/4, 2.5. For the b, well, let me just write this down here then. So times a squared, and we want to write this back as a root, a squared. For the b, we do the same thing, b to the 24 over 4, but 24 over 4 comes out nice. That's just going to be 6. So times b to the 6th power. I can clean it up a little bit. So we'll do plus or minus 2, a squared, b to the 6th, fourth root of 2. I've got a fourth root of a squared, so I'm just going to put them both into the root symbol. And there we go. So that's what the answer is. So a little bit more, but that's because not everything came out as nice as it did in part A. All right. For number 5, solve the equation. So to solve the equation, what we want to do is we want to try and get the exponent by itself. So with this one, we'll divide both sides by 3. X to the 4th equals 16. We can fourth root both sides to undo the x to the 4th. And we get x equals, and we have to be careful because this is an even exponent, so we have to do plus or minus 2. On the other side, here we can divide both sides by -2 to get x cubed equals -27. We can cube root both sides, so we'll get x equals -3. And again, if I want to double check either of those, I can throw those right into Desmos. Cube root of -27. Well, let's do fourth root of 16 since I'm here. See, we get 2. Cube root of -27 is -3. All right, so that works out. Perfect. For number 6, rewrite this expression using the properties of exponents. So what we want to do is rewrite this as 32, we want to try and break that down. So we'll go fourth root of 32. And we got the fourth root of x to the 9th. So for my properties of exponents, this is going to be a lot like one that we just did. We don't know the fourth root of 32, but we could split it up into the fourth root of 2 and the fourth root of 16. So just like the other one, this one's going to be plus or minus 2. So that'll end us with, just like the last one, plus or minus 2, fourth root of 2. For this one, we don't want to break it down. Yeah, let's break it down like that. So we want to find things that have powers of 4. So we could do the fourth root of x, because that doesn't work out. But the fourth root of x to the 8th will work out, because this is equal to x to the 8 over 4, or x squared. So we've got x squared times the fourth root of x. So times x squared times the fourth root of x. So if we put it all together, we get plus or minus 2 x squared, fourth root of 2 x. And we're all set. And again, the only reason I have the plus minus is because this is even. If that was an odd number, like a 3, a 5, or a 7, I wouldn't do the plus minus. It would just be what it is. All right, for number 7, we have to put this one in reduced radical form. So what we see is we've got a cube root of 2a squared and a cube root of 5b to the 4th. So my goal is to try and make it so that this cube root is gone out of here. So if I look at what I got, first thing I'm going to notice is that this b to the 4th, cube root of 5b to the 4th, we can split this up, not that way yet, we can split it up into cube root of 5 times cube root of b to the fourth. So if we want, we can split this up into cube root of b to the third power. That's just equal to b. This one we can't do anything with. This one we can't do anything with. So if we simplify the denominator a little bit, we get 2a squared over b times cube root of 5b. So it looks like we're doing a little bit better. So we got some of these b's out of the cube root, but not everything's out of the cube root yet. So what I need to do is make this into a perfect cube. So I'm going to multiply by what I need to. So I need to multiply by a cube root again. But again, I want to try and get this 3 to go away. Oh yeah. So what I've got to do is think, all right, if I've got a 5, if I had 2 more, that would be 5 to the third power. So that third power would have canceled this 3 out. So let's do 5 squared. I've got b to the first power. I need 2 more to cancel that out. So we'll do b squared. And when I multiply on the top, I got to multiply on the bottom. 5 squared, b squared. So when we multiply this together, we're going to get cube root of 2 times 5 squared, a squared, b squared, over, so of the b that's out here, cube root 5 times 5 squared is 5 to the third. B times b squared is b to the third. All right, well, this is good because now this 3 is just going to cancel out these powers. So that's going to leave me with the cube root. Now 2 times 5 squared is 2 times 25, so that's 50 a squared b squared over, and I've got 5bb, which is 5b squared. So there we go. That's what we want to do for number 7. So that's what it is in reduced radical form. All that means is we want to get rid of the root that's on the denominator. So once we do that, then we're in reduced radical form. All right, for number 8, what's the reduced radical form of the cube root of 135 plus the cube root of 40 plus square root of 125? So first thing we want to do is check to see if any of these are nice. So let's start with the cube root of 135. All right, that's not nice, so we can't do anything with that yet. Let's see what's next. Cube root of 40. I'm feeling pretty good about that. Nope. All right, square root of 125. My square root. Remember, if there's no little number, we could just put a 2 there if we wanted. Nope, none of those work out. So that means we got to do these all by hand. So not too bad, but we want to break them down just like we were breaking down some of the other ones. So cube root of 135. So I got to think again. All right, what are my common cubes? Well, 8, but 8's not going to work because this is not even, so 8's kind of useless for us right now. 27 would be my next one to try. So let's see what happens if we pick 27. Because the cube root 27, we know that's 3. 135 divided by 27. I think that's 5, but just to double check, we can double check. 135 divided by 27 is 5. Okay, so that one works out. So we get cube root of 5. So we know that this is 3. So this one is now 3 times the cube root of 5. All right, cube root of 40 is going to be next. Let's do that where I got some more space. So again, I'm going to start with 8, and I know 8, we can divide 8 by 40, so that's pretty good. So that's going to give me 2. I'm left with this 5. Again, I can't get 3 of anything with that 5, so 2 cube root of 5. All right, square root of 125, so now I have to remember all the square root rules. So square roots, I got 4. That's not going to work. 9, 1 plus 2 is 3, 3 plus 5 is 8, so that 9 is not going to work. 16 doesn't work because it's not even. So let's try 25. Square root of 25 times 5 would be 125. So this is then plus 5 square root of 5. So I'm almost done because when I do reduced radical form, I want to combine like terms. So here I've got a cube root of 5, and here I got a cube root of 5. This one's different because that's a square root of 5. This is a 3. That's only a 2. So I can add these up like variables. 3x plus 2x would be 5x. So 3 cube roots of 5 plus 2 cube roots of 5 is 5 cube roots of 5. And I still have plus 5 square root of 5. And then that's my result. So I'm all done with that point. So we're done with number 8. All right, sounds good. Number 9, we have to multiply these two. So this is just an a minus b times a plus b. So we know we square the first one, we get 9. Oops. And then we know we square the second, oops, we're not going to square the first one, we get 9x. And then we square the second one, so minus 25, and that's it. So that's all we're going to do for that one. If you really want to go the long way, you're allowed to go the long way. To go the long way, we would do our double distributive property. 3 root x times 3 root x plus 5 minus 5 times 3 root x plus 5. And then we double distribute. So 3 times square root of x times 3 square root of x is 9x. 3 root x times 5 is 15 square root of x. Negative 5 times 3 square root of x is minus 15 square root of x. Negative 5 times positive 5 is minus 25. And so we can see that these two terms are equal to 0. So that leaves us with 9x minus 25. So you can do it either way. And I feel that it's a little bit faster to go this way. So that's the way that's easiest. All right. Number 10, rewrite 5 over 2 plus square root of 3 in reduced radical form. So just like when we did our conjugates before, what we want to do is rationalize the denominator here. So since I've got 2 plus the square root of 3, I need to multiply by 2 minus the square root of 3. All right, again, this is an a minus b times an a plus b. So denominator is pretty quick. We get 4 minus 3. Up top, we can just distribute. 5 times 2 is 10. 5 times root 3 is root 3. 4 minus 3 is just 1, so we'll just end up with 10 minus 4. Oops, sorry, 10 minus root. Where's my 5 go? 10 minus 5 root 3. Lost my 5. Again, that'd be over 1. So if I'm just dividing by 1, I don't need to write it anymore. If you want to see it out a little bit longer, again, on the bottom, what we're doing is 2 times 2 minus root 3 to get 4 minus 2. Oops, wrong place again. And then plus root 3 times 2 minus root 3. So then when we distribute, we'll get 4 minus 2 root 3 plus 2 times 2 times root 3. And then root 3 times root 3 is just going to be 3, so minus 3. And so this is what gives me the 4 minus 3 that I have in black, because these will cancel out. And then if I wanted to simplify, 4 minus 3 is equal to 1. So that's why I divided by 1 down here at the bottom. If I want to see the top out a little bit more, what I'm doing is I'm doing 5 times 2 minus root 3. And this one's only a single distribute, 10 minus 5 root 3. And that just gives me the 10 minus 5 root 3 here. So that's it. So that's how we do number 10. Again, the final answer, we already found that one a while ago. It's the 10 minus 5 root 3, but that's what it is. All right, sounds good. For 11, we have to choose which of the following is true. It's another transform question, so we can see that we're inside and we're minus 3, so that means that we need to go to the right 3. So right 3, down 3. Okay, this one looks good. Then we also have a question about the domain or the range. So if we're inside, remember we're dealing with the domain. So I'm going to pick the one that goes with the domain because we are going right 3. Range would be up and down, so that's not what we're doing. We're not dealing with that. And if we want, we can double check it. So square root of x minus 3. If we type it in, x minus 3. So yeah, we're going to the right 3. And then we are starting our domain at 3. So that makes sense. The reference is square root of x. We do start at 0 normally. We're starting at 3 this time. All right. Then number 12, let f of x equals the square root of x minus 1. So again, here we can see that we're just going to the right one. So what I'm going to do is go to the right one. These points, we're just making a nice little sketch. So there we go. Graph f of x, done. What's the domain? We can see we're starting at 1, and then we're going out to infinity. What's the range of f of x? We can see that we're starting at y equals 0, and we're going out to infinity. So since there's a solid dot at the start, that's how we know that we want to have the brackets on the 1 and the 0. Infinity always gets the parentheses. So we're all set. And then we got number 13. What transformations of the parent function of the graph of f of x equals root x produces the graph 3x minus 6 plus 2? So here we got to be really careful because it looks like we've got something down here, but we want to simplify inside of our root before we actually write down any transforms. So to simplify, what we're going to do is say that I can divide both of these by 3. So we're going to get the square root of 3 times x minus 2 plus 2. Then what I can do is say, well, this is the square root of 3 times the square root of x minus 2 plus 2. So I can split up a square root. I'm allowed to split a square root up. And now everything is exactly where it should be. So this is going to be a. This one is going to be h. And then this one's going to be k. So just like everything else that we've done with a, h, and k, with a, we know this is the vertical stretch. So vertical stretch of square root of 3. So that's a little bit tricky, but comes out pretty nice. We have this x minus 2, so that means we're... All right, just going to finish up the last little part. So here we said we had to go right 2, because we have minus 2 inside here. And then for k, k is going to move us up 2. So again, if we want to double check that, we can go ahead and just plot that into Desmos. Let's get rid of this one. And so we had 3x minus 6 and then plus 2. So we can see, yeah, we definitely went right 2 and up 2. And so the hard thing is to actually figure out that square root of 3. So it does look like it is a little bit stretched, because again, if I wanted to look at just the square root of x minus 2 plus 2, I mean, you can't really tell what the stretch is just by looking at it. It is something that you have to calculate. But what you can do is say, well, if I want to go 1 over 2 plus 1, I should be at the point 2 plus square root of 3. And I can see that that points directly on the line. So the reason I picked 2 plus 1 is because that's the x-coordinate that I'm starting at. If I go over 1 in x, I should go at the y-coordinate I'm starting at, and then plus the stretch. So if I really want to double check it, I can, but kind of a complicated choice to check. It's a little bit easier just to do it by hand. So that's what we got for number 13. All right, and then the last one, there's only one more to go. So just number 14, what radical function is represented by the graph? So again, what we want to do is find kind of where the middle is, kind of find where it would rotate around to make it the same. And that looks like it's right here. So what we want to do is we want to make the equation from that point. So we know that the original equation has to be y equals a. And this is a cube root because it looks like a cube root function of x minus h plus k. So we're just going to fill everything in that we can see. So k is kind of nice. We can see we're going 1, 2, 3 up. So we know we're plus 3. So that's pretty easy. Cube root of x doesn't change. So that's easy. For h, we see this is another one where we're 2 to the right. So it looks like it's another minus 2. That's fine. Then we have to look for a. So again, for a, what we want to do is go 1 over and see how far up we went. Well, if we go 1 over, we go 1 up. So 1 over 1. Cool. So it looks like that's about it. If I want, I could clean that up. Y equals 1 divided by 1 is just 1. So cube root of x minus 2 plus 3. And that's everything. So that's everything that we got for that one. All right.